Hi, today I will show you how to simulate horizontal centrifugal casting in Polygon software. I start my PoligonSoft and I start mesh generator. Go to geometry mode and go to file menu, input, step. Now I find my step file with the geometry. Here it is. Select no in this dialog because I have my geometry in millimeters. Do you want to create a partition? Yes, I want. And geometry input completed successfully. And now we see here three solid bodies. Here is a mold. I will rename it mold, and here is a casting. And here is a mold number 2. Now I go to mesh mode, click partition in tree and click create mesh button here. Go to 2D tab and select algorithm NetGen 1D2D and create new hypothesis NetGen 2D parameters. And here I input the max and minimum size of finite elements, for example 10 millimeters is a maximum size and 1 millimeter is a minimum size, and fineness is coarse. It's okay. And I will create another mesh for casting. Right button mouse click here, create submesh, and select casting here, and I see it here in geometry field. Go to 2D tab and algorithm is NetGen 1D2D and a new hypothesis NetGen 2D parameters, for example 5 millimeters for maximum size mesh and 1 millimeter for minimum size mesh and coarse fineness. Okay, apply and close. And now I will create 2D angle mesh. Right button mouse click and select compute submesh. Successful, and I see my mesh. I think to remesh it because these elements are too big for this case. Right button mouse click, select edit submesh, go to 2D tab and press this button to edit my parameters, and here I want to select 2 millimeters maximum size. Apply and close and click here compute, or here compute submesh. It's okay. Now it looks good. And now I will compute all other elements. I think it's enough because here is 1, 2 and 3 elements. It's okay. And now I will create 3D mesh, but first of all I will check my 2D surface mesh. Press this button and here I see checking result 0, 0 and 0. My mesh is fine. Close this dialog and press this button compute 3D mesh to compute 3D volume mesh. And I need to select this main mesh first of all and press this button, and volume mesh will be computed automatically. Finished. Now right button, mouse click here and select create groups from geometry, and select in this tree all objects, all bodies from partition item here, and I see them here, and click and apply and close. Now I can export my mesh. Right button, mouse click here and select export med file, and I want to create a new folder and save it here. Yes, okay, now I can close this mesh generator. I can save my study before closing this application. For example, here I can close this window, and now I start the processor of PoligonSoft master. Click open geometry button, button, it's a mesh generator, units millimeters, okay. Now I need to find my folder, here it is, and open this file. I will press no because I will set up new case, and I don't want to use previous settings from previous simulation now, so I will press no here. Now I see my geometry, and I will press volume index mode here, this button. Yes, and I see in several colors my volumes. And this volume, this body is a tube, the casting. Double click here and select casting type and index number 1. It doesn't matter now. Yes. Now it's a casting. Here it is. And this volume, it's a mold, and this volume is mold 2. I will make double click here and select mold type. Okay. Now I have one volume here, it's a casting, and two volumes here, it's a mold. I have a direction of y-axis along my horizontal rotation axis, and this is right, because in PoligonSoft we can simulate usually only centrifugal casting with vertical rotation axis, and as we want to simulate some other process, we need to position our geometry along vertical axis y. So for this case it's the right position. I can use it, and I can set up rotation axis along this direction. But now I need to set up materials for casting and mold. Usually we use templates for some casting types, for example for sand casting, and we have template for investment casting and for high pressure die casting, but I don't have a template, special template with some settings for centrifugal casting, and I will prepare it right now. As for alloy properties, I will use some cast iron, for example. So double click here, this button, go to my PoligonSoft database, iron, let it be this iron. It has liquidus temperature 1231 degrees and solid temperature 1158 degrees. And now I need to stop mold materials. Double click here and edit button, and I will use new template, and for example for this region number 2, the volume index number 2, I will use here some steel for my mold. Right button mouse, click here and load region from base. And here I can select some steel from this base, for example steel carbon. And here is the heat capacity and conductivity for the steel, and I will press save button to save it to my folder. For example here, and I will call this file cc, that means centrifugal casting save. Okay, and I see it here. And now heat transfer file, I need to create it, and to set up some heat transfer parameters between casting and mold, and between casting and mold and environment, and between mold and environment. So double click here, edit button, and I can select this filter in project, and we'll see only the boundaries that I use in this project. I can switch this mode here to boundary index mode here, and see that casting has this boundary number 1. You see this color, it's a boundary between casting and mold, and if I will show off my casting, you will see the same boundary here. And I have this boundary number 17 between casting and environment, and this boundary number 18 between mold and environment. So I have these 3 boundaries. They were set up automatically, and I can set up some heat transfer parameters for these boundaries. For example, as for casting mold boundary, I think 1000 is a good efficient, but we can use 2000 for example. And as for external boundaries, here is the convection, and I think these settings are okay for these boundaries. But maybe as we use iron mold, I can use here emissivity 0.8 as for metal materials as for casting. These parameters are the same now. And I will press save as and save these settings to my folder right here. For example, cc. We'll call these files as cc. Save, close, and I see this path here. As for alloy temperature, I think 1350 is okay, and mold temperature, for example, 400 degrees. And now it's enough. I can close it. And what about rotation? I need to stop this rotation axis. Go to edit menu and select rotation. And now I have a mold section here. I can turn off this section and show grid, show mesh. And if I will click here with the control button on my keyboard, I will select the center of rotation axis, and here we see the direction of rotation. And if you want to change this direction, you can press here. So this is a rotation axis, and as for rotation speed, we need to set up some value from the technology, and I don't know, maybe 400 pounds per minute, for example, and press OK. And now I can select mold materials. I can switch on volume indexes mode, and these indexes in these colors means mold materials. And if I double click on this mold volume, I see that my steel carbon is here. It's number 2. I will check and press OK, and the color was changed. And I double click here on this part of the mold and select this material and click OK. Now it's OK. I have steel mold and iron casting. So as we use in PoligonSoft gravity vector direction against Y axis, but in our case in horizontal centrifugal casting, the right position of the geometry is not like this, but like this. So we can't simulate filling, but we can simulate solidification, and we can simulate press, and I will show how to do it. Go to the Start Simulation Parameters window, and on Flow tab, this parameter Enable Flow Model must be switched off. In here on Solidification tab, you see Enable Solidification Model is switched on, and here we have calculation time step 1 second, it's okay, and output time step 10 seconds, it's okay too. And simulation stop condition solid temperature, but we can set up here some other conditions. For example, casting temperature when we stop rotation. For example, we can set up here stop temperature condition, and this stop temperature, for example, 400 degrees. So that's all here. And on porosity tab, I want to use macro porosity model and micro porosity model. Save porosity results, and I need to select alloy properties file. Double click here, press this button, go to PoligonSoft database, to iron, and select my iron. Here it is. This is some porosity, some properties, alloy properties for porosity simulation. And that's all here. And on stress tab, I can enable stress model, and calculation time step, I can set up here some large value, because time step for stress model will be selected automatically and it will be changed during simulation. So I can select here, for example, 50 seconds. And now I need to select alloy stress properties file. Double click here, press this button, go to PoligonSoft database, and select here some mechanical properties, for example, for this cast iron. And I can select how to simulate contact between casting and mold. And the most simple way to do it is to select a rigid mold. If we select it, we don't need any mechanical properties, any stress properties for mold. and we don't need any additional boundary conditions for mold. It's a very simple and effective way to simulate stresses in casting with taking into account contact between casting and mold. Now I need to set up output time step, and I think 100 seconds is a good variant. Then I can simulate stress in casting not only during solidification and during cooling in mold, but after mold removal. And if I want to do it, I need to check this field, simulate stress after mold and gating system removal. I have no gating here, but I have mold, so mold removal temperature will be, for example, 300 degrees, or maybe it can be lower than final temperature here. We'll stop thermal temperature simulation when casting temperature will be lower than 400 degrees, but we can remove mold later, and so I can select here temperature, special temperature for this operation, for example 200 degrees. And that's all, and here I can select some additional results what I need to analyze later. By default, Polygon will simulate stresses, deformations, and if I want to simulate some other results, I need to check these boxes. For example, I want to analyze plastic strains, and if I want to simulate hot curing, I can select this field. And as for displacement, we can analyze displacement magnitude by default, and if we want to analyze some components of displacement vector, we can select it here. For example, if you want to analyze y component of displacement vector, means displacement in this direction, we can select this checkbox, and so on. And now we are ready to start. I press simulation button, and I will create new folder for my simulation and save this file here, and simulation starts. So summary: we can't simulate filling during horizontal centrifugal casting because in PoligonSoft we have gravity vector along this y-axis, and we can set up rotation axis only along this y-axis too. But if our centrifugal force is much higher than gravity, and in horizontal centrifugal casting centrifugal force is much higher than gravity, we can simulate this type of centrifugal casting, but we need to orient our geometry like here and set up rotation axis like this along y-axis, but we will simulate only solidification. Doesn't matter that our gravity vector has wrong direction. So we can see results during the simulation, and as we have first save result, after 10 seconds we can go to the post processor. You can press this button and start enrich model. And here we can see temperature field, and press this button, open temperature file. Here it is, open, and we see our geometry, and this colors temperatures, and we see scale here, and time scale, and this player to move along the simulation to the last step, for example, and last step is 10 seconds right now. And here we see temperatures, and I can change my background, for example, click here and change it to white and press this big button, it's apply button, and I can change colors of the scale. For example, from this, select from the list this scale and press apply button again, and I can switch off mold and see temperature field of casting of tube. I can change the scale here. For example, I can stop first position, it's my initial temperature 1350 degrees, and I can switch off these checkboxes and select the final temperature. The lower temperature is 400 degrees. Press apply button and see the deviation, and I can fix this position, yellow color for example, and enter here solidus temperature. Solidus temperature is here 1158 degrees. Press enter and press apply button. Now we can see temperature results. Here is a player and we can go through the process. And see how temperature changes in casting. And we can switch on display pipes, and we can see how wall thickness changes due to piping, due to shrinkage. You can see it. You can see it here. And we can see porosity field. Press open porosity button and load this file with porosity field. And final step is more interesting to see the deviations, and I have a black color here. And we see porosity area here. And to analyze stress fields and deformations, we need to wait some more time because now it's in progress.